And why? Suppose a firm sends out two kinds of promotional facsimiles. One kind contains only text and requires 40 seconds to transmit a page. The other kind contains grayscale pictures that take 60 seconds per page. Faxes can be 1, 2 or 3 pages. So the number of pages is 1 to 3. Let the random variable L represent the length of a fax in pages. So SL is equal to 1, 2, 3. So it can be either 1 page or 2 pages or 3 pages. Let the random variable T represent the time to send each page. So 40 seconds to send text only page and 60 seconds to send a grayscale picture page. After observing many fax transmissions, the firm drives the following probability model, which says that to transmit one page or send one page of text only, it takes 40 seconds, and the probability of sending such page is 0.15, and probability of sending a single page having a picture is 0.1. Probability of sending two pages having text only is 0.3, and probability of sending two pages having pictures is 0.2. And similarly, probability of sending three pages having text only is 0.15, and probability of sending three pages having pictures is 0.1. So let D is equal to G of L of T, L comma T is equal to L into T. Simply we will multiply the length or number of pages by the time duration. Be the total duration in seconds of a fax transmission. Find all of the possible durations SD, the PMF PD, and the expected value E of D. So total possible durations are either you are going to send one page of only one page of text only, or one page of pictures only, or two pages of text or two pages of pictures, then three pages of text and three pages of pictures. So these are the possible durations. So the possible durations are 40, 60, 80, 120 and 180. So now we will see the PMF of the values probabilities. So here we can see that 1 comma 40, for 1 comma 40 we have the probability is 0.15. One page 40 seconds, the probability is 0.15. For 1 comma 60 it is 0.1, and for 2 comma 40 it is 0.3. For 2 comma 60 we can see that this is possible, this 120 seconds is possible in two ways. Either you send two faxes of 60 seconds or three faxes of or three pages of 40 seconds. So we see that the probability of 2 comma 60 is 0.2 and 3 comma 40 is 0.15. So altogether it is 0.35. And for 3 comma 60 it is 180, and the probability is given is 0.1. So we can calculate this expected value over here using this equation as well. How do we calculate it? We simply plug in the values over here for g of x, gx comma y is equal to L into T, as we have seen over here before, this one, and multiplied by the probability. So 1 from here, 1 multiplied by T, which is in this case 40, multiplied by 0.15, which is this probability. Then 1 multiplied by 60 multiplied by the probability, which is 1 into 60 into 0.1. Then 2 into 40 into 0.3, and 2 into 60 into 0.2, 3 into 40 into 0.15, and 3 into 60 into 0.1. So just multiply all these and add them, and we get 96 seconds. So you can see that the result is the same. This equation over here, this one gives us the same result as we have calculated over here. Two variables, variance and covariance. Variance refers to the spread of a data set around its mean value. We have talked about it in detail in the initial videos, so I'm not going to into the detail of this one. What is variance? I have just quoted it again over here in case if somebody has forgotten. The variance of the sum of two random variables is simply variance of x plus y, which is equal to variance of x plus variance of y plus 2 expected value of x minus mu, which is mean, into x, and by minus mu into y. Covariance is a quantitative measure of the extent to which the deviation of one variable from its mean matches the deviation of the other from its mean. So what we do is that we match the two values of two variables, and we see how much they match with each other. The variance of one variable, or the deviation of one variable, with the deviation of the other one. So the covariance of two random variables x and y is simply e into x minus mu x and y minus mu y. Now, two variables correlation. What is correlation? Covariance is interesting because it is a quantitative measurement of the relationship between two variables. Covariance tells us and gives us the quantity, how much the two variables vary against each other. Correlation between two random variables is the covariance of the two variables normalized by the variance of each variable. So simply what we do is that we calculate the covariance and then we divide it by the variance of x and variance of y, or you may say we divide it by the standard deviation of x or and standard deviation of y, because we are taking here we are taking the root. So what does it do? What is the purpose of this division? It normalizes the value of covariance between -1 and 1. This normalization cancels the units out and normalizes the measure so that it is always in the range from -1 to 1. If two variables are independent, then their correlation will be 0. However, like with covariance, a correlation of 0 does not imply the independence. So the reverse is not true. If the two variables independent, then their correlation will be 0 for sure. But if we calculate the correlation between two variables and you get the result 0, then it doesn't mean that these two variables are independent as well.